Hey guys, this is Mrs. Lehman. Hi, how are y'all? I miss you. Here's your notes for 8.4. We have a couple theorems, so notes and your theorem sheet if you have that available. This is the tangent chord theorem. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So what that means, here's your tangent, here's your chord. AB is the chord. Point of tangency is A. And the measure of each angle formed, so angle 1 is going to be half the measure of arc AB. And angle 2 is going to be half the measure of arc BCA, which is a major arc. We know that because it's 3 letters. AB, minor arc, because it's 2 letters. Example 1, line M is tangent to the circle at point R. We have the chord RT, and we are trying to find the measure of arc RST, given the angle at R right here is 102. So the measure of RST equals 2 times 102. And the measure of RST is going to be 204 degrees. BC is tangent to the circle at point B. Find the measure of angle CBD, which is represented by 5x. So we would have 2 times that angle is equal to the 9x plus 20. Which is going to simplify to x equals 20. We're still looking for angle CBD, so we need to go back and plug that in. So angle CBD is going to be 5 times the x we found as 20. So measure of angle CBD is 100 degrees. The interior intersection theorem, if you have 2 chords intersect in the interior of a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So here's a picture of what that's going to look like. Here's our 2 chords that are intersecting. And so the measure of angle 1 is going to be the sum of the arcs that are formed there. So DC and AB go with angle 1, so you'd add those together and divide by 2. If we were looking for angle 2, we would add BC and AD together and divide by 2. Example for that, here's the angle we're looking for. It's where 2 chords are intersecting inside the circle. So we're going to add these 2 arcs together and divide by 2. So angle X is going to be 1/2 of PS, 106, plus the measure of RQ, which is 174. Add those together and divide by 2. So 1/2 of 280, which is 140. So again, interior angle, where the chords are intersecting inside the circle, you're going to add the arcs and divide by 2. The exterior intersection theorem, if you have a tangent and a secant, or 2 tangents or 2 secants that intersect outside the circle, in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arc. A diagram for this, here's where you have a secant, AB, and then this tangent. And that's going to be, angle 1 is going to be 1/2 the difference of the big arc, BC, minus the small arc, AC. If we have 2 tangents, then that involves the whole circle, if you notice. So it would be measure of angle 2 is going to be the big arc, the major arc, minus the minor arc. So measure of angle 2 would equal 1/2 of the difference of arc PQR minus PR. Here we have two secants that intersect outside the circle, so we're looking for angle 3. It's going to be 1/2 the difference of XY, the bigger arc, minus the smaller arc. So measure of angle 3 equals 1/2 of the bigger arc XY minus WZ, the smaller of the two. Example 4. So here we have our angle outside the circle. It's 72. So it's going to equal 1/2 of the bigger arc, 200, minus X. So 72 degrees, the angle, is equal to 1/2 of 200 minus X. Multiplying both sides by 2 to get rid of that 1/2, that gives us 144 equals 200 minus X. X equals 56. Example 5, here we have an angle, again, outside of the circle. Again, this involves the whole circle. So the first thing we need to do, since we don't have a measurement over here, we don't have a measure for the bigger arc, we have to do 360 minus 92 to get the major arc ABC. Then we'll have the measure of that big arc to use in our formula. So the angle, as these tangents intersect outside the circle, X, is equal to 1/2 of the major arc minus the smaller arc, 92, which gives us 176, and 1/2 of that, or divide 176 by 2, you get X equals 88. All right. A satellite, this seems like the more challenging of the problems. A satellite in geostationary orbit above Earth's equator has a viewing angle of Earth formed by two tangents. So here we've got a circle. We've got the two tangents intersecting outside the circle. So we've got the 17.5. And what is the measure of the arc of Earth that is viewed from the satellite? So this arc here is what we're looking for. So that's going to be the big part of the circle back here, the major arc back here, is 360 minus X. You got to remember that the whole circle is 360. So this is going to be represented by 360 minus X for the bigger arc, and then X for the smaller. So the angle outside the 17.5 equals 1/2. We're back to just our same formula, 1/2 of the bigger arc, 360 minus X, minus the smaller arc, which is X. And let's go ahead and multiply the left side, or both sides, by 2, which gets rid of that 1/2 and makes 17.5 35. Equals 360 minus 2X as we simplify that. So we end up with negative 325 equals negative 2X. Divide by negative 2, and we get 162.5 for the measure of the arc of Earth right here as viewed from the satellite. All right, that's the end of the notes, and good luck with the practice. Let me know any questions that you guys might have. Oh, I did want to share a joke. I know you guys, are, struggling without my corny jokes in geometry. So there's this guy who flew so close to the sun, he was able to touch it in exactly one spot. After that, he was a real tangent. Sorry, I had to.